Okay, so we are doing DU MME 2024. Question number 1. Maximize profits. Pi is equal to 64 minus x. 64x minus 2x square plus 96y minus 4y square minus 13. Subject to the production constraint x plus y less than or equal to 36. So this is a maximum minimization problem with inequality constraint. So we will be using the Lagrange's method to solve this. Okay. So let us form our Lagrange function. So our Lagrange function Lxy lambda will be equal to my profit function 64x minus 2x square plus 96y minus 4y cube square minus 13 minus lambda, and what is my constraint? Gxy less than or equal to 36. So by gxy, which is x plus y, and you have to bring 36 with a negative sign inside this. So this is my Lagrange's function if I want to maximize this profit. Okay. Now, what are the conditions for maxima minima? The necessary condition for maximum minima is that the partial derivative of L with respect to X and the partial derivative of L with respect to Y both should be equal to 0. Okay. So what is the partial derivative with respect to X? 64 minus 4X minus lambda into 1. This should be equal to 0. Also, we should have mm, 60 with respect to y 96 minus 8y minus lambda equals to 0. So from these two equations, I have lambda is equal to 64 minus 4x and also lambda is equal to 96 minus 8y. Okay. So we have 64 minus 4x is equal to 96 minus 8y. So cancel 4 on both the sides. So 16 minus x is equal to 24 minus 2y. So x minus 2y is equal to minus 8. This is my first equation. This is from the necessary conditions for maxima and minima. All right. Now next. So we have to then consider two cases. So what is case 1? So case 1 is lambda is positive. Always remember that lambda is greater than or equal to 0. Okay. So this is lambda is positive. So if lambda is positive, then x plus y has to be equal to 36. That is our condition. Because if to maximize, I want this to be maxima. So if lambda is positive, let this be equal to 0. So solve these two equations. X plus y is equal to 36 and x minus 2y equals to minus 8. So minus plus plus. So y will be equal to 44 upon 3. So from here, x plus y is 36. So x is equal to 36 minus 44 upon 3. So 108 minus 44 upon 3, 64 upon 3. So the possible point where I can have my maxima is P 64 upon 3 and 44 upon 3, and this happens when lambda is positive, that is x plus y is equal to 36. Okay. Now let us see what I get for my lambda from these two conditions. From this point. Okay. So lambda is equal to 64 minus 4x. So lambda is equal to 64 minus 4 times 64 by 3. Okay, which is 64 common 1 minus 4 by 3, which is 64 into minus 1 by 3, which is negative. So lambda is coming out to be negative. So we do not have a solution in case 1. So there is no a solution which will give us maximum of profit in this case. So now we will have to go to case number 2. Okay, so this was our case number 1. So what happens in case number 2? Let's see. Okay. So in case number 2, what happens? We have to consider the case when lambda is equal to 0. Here x plus y can be less than 36. Okay. So, but lambda becomes 0. So lambda is equal to 0. So now lambda is 64 minus 4x. So 64 minus 4x is equal to 0. So x is equal to 16. Also lambda is equal to 96 minus 8y. So 96 minus 8y is equal to 0. So 96 is equal to 8y. So y is equal to 96 upon 8, which is 12. Okay. So now my point where I can get a possible maxima is 16 comma 12. Okay, I just have to check whether this constraint is satisfied or not. X plus y less than 36, less than 36. So 12 plus 16 less than 28, that 36, because 28 is less than 36, that is true. So I am getting a maxima of profit at 16 comma 12 as per this case. Okay, so let us calculate pi max. So pi max will be 64 into 16 minus 2 into 16 square plus 96 into 12 minus 4 into 12 square minus 13. So pi max. So we have a 16 into 2 common from the first. So we will be left with 4 over here. So no, this is, we'll be left with 32 in this, because if I take 16 into 2 common, so I'll be left with 32, and over here I'll be left with 16. This is how we do simple calculations. Then here we can take 12 into 12 into 4 common. So here we will be 112 will go from here, 112 will go from here. So it is 12 times 8, 96. So then I have 8 left. So I'll have 2 left over here, and minus 1 and minus 30. So it is 16 times 2 times 16 plus 12 times 12 times 4 minus 13. Okay. So 16, 16, 256 into 2, 512 plus 12 and 12, 144. 144 times 4 is 576. Let us check 144 times 4. Yeah, 576 minus 13. So this is a 512, and then 576 minus 13 is 563. So it should be 571075. So 1075 is the maximum value of our profit function. This is how we solve for the profit function using Lagrange multiplier method.